fractional indices. So for this particular lesson, it can be easy to understand if you go through squares, square roots, cubes, cube roots, and indices. Applying the law for an index of an index, we know that any base a to the power m over n is equal to a to the power m to the power 1 over n, or a to the power 1 over n to the power m. A to the power negative m is equal to 1 over a to the power m. When you are given a negative index, you can change it to with a positive index by introducing a numerator 1. And a to the power negative m over n is equal to 1 over a to the power m over n. The number 4 to the power 3 over 2 using the law of an index to an index may be expressed as 4 to the power 3 to the power half. 4 to the power 3 is the same as 4 times 4 times 4, which will give us 64. Power half means square root, so the square root of 64 is equal to 8. So we are saying 4 to the power 3 is the same as 64. Power half means square root, so the square root of 64 is equal to 8. And then we have 4 to the power 3 over 2. 4 to the power 3 over 2 is the same as 4 to the power half to the power 3. So 4 to the power half is the same as square root of 4, which is 2. 2 to the power 3 is equal to 2 times 2 times 2, which will give us 8. So 4 to the power half is equal to the square root of 4. The square root of 4 is 2. 2 to the power 3 is equal to 8. So this just confirms that any base a to the power m over n is equal to a to the power m to the power 1 over n, or a to the power 1 over n to the power m. Example. Evaluate, we have 64 over 125 to the power 2 over 3. 2 over 3 is the same as either 1 over 3 times 2 or 2 times 1 over 3. So what we are going to do is to find the cube root of 64 over 125 and then we'll square it. So the cube root of 64 is 4. And the cube root of 125 is a 5. A cube root is a number which you are supposed to multiply by itself 3 times to get a 64, which is a 4. The number which you are supposed to multiply by itself 3 times to get a 125 is a 5. So the cube root of 64 is a 4 and the cube root of 125 is a 5. So from there we are going to square them. Our answer will be 16 over 25. Then we go to the next one. We have evaluate 3 over 4 to the power negative 2. Since we have a negative index, we'll change it to a positive by introducing a numerator 1. So we are going to have 1 divided by 3 over 4 squared. Since we have a numerator 1, the division sign will change to multiplication, and then we'll have to find the reciprocal of the divisor. So the 4 will become the numerator and the 3 will become the denominator. So we are going to get 4 over 3 squared, which will give us 16 over 9. We go to the next one. We have evaluate 81 divided by 16 to the power negative 1 over 4. Plus 81 over 16 to the power 0. So the first thing we are going to do is to change that negative 1 over 4 to a positive by introducing a numerator 1. When we introduce that 1 divided by 81 over 16, it will become 16 over 81. Then any base a to the power 0 is the same as 1. So from there, what we are going to do is to find the 4th root of 16 and the 4th root of 81. Which number are you supposed to multiply by itself 4 times to get 16? 2. Which number are you supposed to multiply by itself 4 times to get 81, 3. Then 81 to the power 0 is the same as 1. 16 to the power 0 is the same as 1. So it's going to look like that. From there, we'll find the common denominator, which is a 3. 3 into 3 will give us a 1. 1 times 2 will give us a 2. 1 into 3 is a 3. 3 times the numerator 1 will give us a 3. So we are going to have 2 plus 3 divided by 3, which will give us 5 over 3. Convert 5 over 3 to a mixed fraction. Our answer is going to be 1, a whole number, 2 over 3. We continue. Solve for y. We have 1 over y to the power 2 over 3 is equal to 9. So what we are supposed to do is to find the value of y such that when we replace it, it's going to give us a 9. Since y is the denominator, to make it a numerator, it will change to a negative index. So 1 over y is the same as y to the power negative 1. Using the index of an index, we are going to get y to the power negative 2 over 3. Now, since we want to remain with just y, we'll have to multiply both sides by the reciprocal of negative 2 over 3, which is negative 3 over 2. So we are going to introduce it both sides. What we want to remain with on the left is a power 1. So when we multiply negative 2 over 3 times negative 3 over 2, we are going to remain with a 1. Then 9 to the power negative 3 over 2 is the same as 1 over 9 to the power 3 over 2. We are supposed to find the square root of 9 and then cube it. The square root of 9 is 3. 3 to the power 3 is the same as 3 times 3 times 3, which will give us a 27. Therefore, our y will be equal to 1 over 27. That is our answer. So for x, we have 121 over 49 to the power x is equal to 1, a whole number, 4 over 7. So what we are going to do is to change that 121 in power form. 121 is the same as 11 squared. 49 is the same as 7 squared. And then 1, a whole number, 4 over 7 is the same as 11 over 7. We'll do that. Using the index of an index, we are going to multiply the powers. That's going to give us 11 over 7 to the power 2x. We'll change the 11 over 7 into an index by introducing a power 1. So 11 over 7 is the same as 11 over 7 to the power 1. From there, we are going to equate the powers. So we'll say 2x is equal to 1 because the bases are the same. 2x is equal to 1. To remain with x, we'll divide both sides by the coefficient 2. Therefore, our x is equal to half. We go to the next one. Solve the equation 8 to the power x is equal to 64. We want to find the value of x such that when we replace it, it's going to give us a 64. So to do that, we are going to change 64 and express it in power form so that it has the same base as 8. 64 is the same as 8 squared. Since the bases are the same, equate the powers. Therefore, our x is equal to 2. That is our answer. Solve the equation x to the power 1 over 3 is equal to 4. To find the value of x, what we are going to do is to introduce the reciprocal of 1 over 3 on both sides. The reciprocal of 1 over 3 is 3 over 1. So we introduce power 3 on both sides. So when we multiply 1 over 3 times 3, we are remaining with a 1. 4 to the power 3 is the same as 4 times 4 times 4, which is giving us a 64. When we replace a 64 where there's x, It means we have to find the cube root of 64, which is the same as 4. Find the value of n if 4 to the power n is equal to 2 squared times 4 squared. So what we are going to do is to change that 2 squared so that it has a base 4. 2 squared is the same as 4 to the power 1. So when we do that, then we know that the product rule states that when you are multiplying indices which have the same base, add the powers. We are going to add 1 plus 2 as a power. So we have 4 to the power n is equal to 4 to the power 1 plus 2. Since the bases are the same, we equate the powers. So our n will be equal to 3. Question 9. Given that 5 to the power x minus 1 is equal to 125, find the value of x. What we are going to do is to change 125 into a power with a base 5. We have to have the same base. 125 is the same as 5 to the power 3. So we are going to say 5 to the power x minus 1 is equal to 125 is the same as 5 to the power x minus 1 is equal to 5 to the power 3. From there, we are going to equate the powers. So our x minus 1 will be equal to 3. To find the value of x, we'll move the negative 1 from the left to the right, which will give us x equal to 3 plus 1. Therefore, our x is equal to 4. As simple as that.